Hello, everyone. My name is Arad, and I head the horizontal data science and machine learning group in PayPal. Today, I will share with you some of the learning and insights that we've gained while building effective machine learning solutions while fighting fraud. Many of you may look at curves similar to that in your day-to-day work, but this is actually not an ROC curve. This curve demonstrates the progress in facial recognition over the years. What is interesting and important to note about this curve is that the performance of these algorithms probably remains the same today as it was decades ago. And the reason is because the face of the human has not changed much in the last 200,000 years. The same assumption could be made in many machine learning problems, like facial recognition, voice recognition, navigation on a map, or even playing some games. These machine learning systems can safely assume that the world that they're solving for is not changing much. And even algorithms that try to tell cats from dogs. But in some other cases, the world may change. In these cases, we may need to change the way that we train and build our machine learning solutions. For example, in recommendation systems, we may have to train our algorithm repeatedly, and we may need to change the way that we build our training sets to do so. But even with that, we don't have to fundamentally change the way that we do machine learning. In other cases, the world just changes in reaction to our action and reaction. For example, when you use a navigation software, the way that we write traffic changes where congestion builds up. Or in a trading algorithm, the way that algorithm works to trade changes the behavior that other traders, humans or AIs, will react to the market. And this can sometimes lead to unexpected results. But there's another class of problem. And this is a class in which the world actually changed significantly to our action. This class can be further broken into collaborative and adversary problems. In the collaborative world, all of the different AIs try to solve the same problem. While they may be competing with each other, they don't take direct action to attack or subvert each other's work. And usually they have much to gain by working together. For example, if we take the case of self-driving cars, if they share information, if they give each other the right of way, and if they keep the right distance, while one will improve, the performance of all of them will improve together. This is not the case in an adversary solution. In an adversarial solution, our adversary, whether human or AI, will take direct action to change the world in a way that will reduce our accuracy, will reduce our recall as we try to solve the problem. Sometimes they will even change the world before we even train our models, all in the goal of making it harder for us to tell the goods from the bads. This is the problem that we can see in spam filtering, in antivirus software, in cybersecurity, and of course, in fraud mitigation. What the frauder is trying to do is make their activity look like the legitimate activity, or in other words, make the cats look like dogs. In order to cope with this situation with adversarial machine learning, we have to change the way by which we design, evaluate, and deploy our solutions. We have to take into account time to market. We have to take into account the way we do feature selection, and we have to invest in monitoring our solutions. In these situations, the fraudsters gain ground all the time. As they gain ground, our losses may increase. That means that we need to take into account how frequently we have to train and redeploy our solutions. But taking that into account is not a simple task. We have to think about how long it takes to train a model, how much we may be losing, how quickly our solution degrades, and what is the marginal benefit of building and continuing training the model. The answer is not always that getting a better model will give you the best business performance. Another thing that we have to take into account is feature selection. It is not enough to look at how good the feature is on our training model. We have to also think about whether features are resilient over time. For example, in the world of fraud transactions, the time of a purchase is completely in the control of our adversary. Whom they buy from, they may have some control. But if they buy some goods and they need to get their hands on them, then the shipper address is something that's very hard for the fraudster to manipulate. So we need to take those things into account as we build our solutions. As we said, degradation is inevitable, but there's some things that we can do in order to slow it or prevent it. The first thing to do, we want to slow the attacker. We want to keep her in the dark. So we want to keep limited information about how we train our models, which modeling techniques we build, how we build our training sets, and how we evaluate them. We also want to limit the fraudster's ability or the attacker's ability to probe our system. As soon as we release a solution, the fraudster will try to figure out where is the weak point. So in order to that, we want to limit the speed by which they can probe our system. We want to provide them with wrong answers sometime, or even provide with very laconic answers. Last but not least, we have to expand our ability to monitor. Because the one thing that we don't know is the unknown unknowns. That is, when our system has been subverted. For that, we need to come with ingenious ways in order to monitor our solution and know, by using additional data sets and additional techniques, when a fraudster may have found a hook into our system. And last but not least, the human factor. We have to keep thinking ahead to predict what the attacker may do and build our solutions in a way that will make it harder for the attacker to defeat and bypass them. In conclusion, the world is changing. It is not stationary. As we build solutions in an adversarial situation, we have to come up with new methodologies, new techniques, new disciplines on how to build machine learning and how to train models and solutions. These techniques are not usually taught in the courses and not taught in classes. So we keep investing in this technique, because in the adversarial world, if you don't move forward, you go backward. We have to remain and be smarter than the attacker, because this is the only way to win in the adversarial race. Thank you so much, and we hope to see you in our booth and come to learn more about how we solve and deal with adversarial solutions. Thank you.